I'm Gretchen Sable, SSTS Coordinator, and with me today is Mark Westpatal, the SSTS Technical Policy Lead for the Pollution Control Agency. This is Talk 4 of the administrative series for program administrators, and we're going to be talking about SSTS principles. This is the basic things you need to know about septic systems to help you with your job. Broadly, we're going to talk about such fascinating topics as what is sewage, which may sound obvious, but it's a little bit less obvious than it seems, how an SSTS works, what types of SSTS are allowed in Minnesota. We're going to talk about some public health outcomes. Why do we do this, and what's the most important things? What does it mean to have an imminent threat to public health and safety, and the other term, failing to protect groundwater? We'll talk about those. And then we'll talk about some other environmental outcomes, including things that you need to regulate to local government, like setbacks, and also options for systems relating to pre-treatment. First off, what is sewage and why does it need treatment? Sewage is wastewater. You talk to a kid, what is sewage? It's the toilet waste. Well, sewage is wastewater from domestic activities such as cooking, cleaning, laundry, and bathing as well. Exposure to sewage through ingestion or bodily contact, which means stepping in it and that kind of thing, can result in disease, severe illness, and in some instances death from the bacteria, viruses, and parasites contained in the waste. When we use the term SSTS, that stands for Subsurface Sewage Treatment System. What that means is that it keeps the wastewater underground, it's subsurface. It prevents discharge of sewage to surface waters, uses soil to treat wastewater by removing pathogens, and then setbacks from groundwater, wells, and surface water provide additional protections, and we'll talk more about that as we go through the session here. First, though, we're going to show you a video that comes from St. Louis County and describes the elements of a septic system and how it works. St. Louis County is the Minnesota county that extends from Duluth north to the Canadian border. Information in this video applies to all areas of Minnesota, even though St. Louis County is the only area mentioned. This video was funded through a grant from the National Oceanic and Atmospheric Association, also known as NOAA.
If you live in St. Louis County away from areas connected to a municipal sewer, on-site wastewater treatment and dispersal must be considered in the current use or proposed development of your property. Wastewater contains disease-causing pathogens, chemicals and nutrients that, if left untreated, can be harmful to both public and environmental health. Untreated wastewater cannot be flushed or drained into the environment. Nutrients and chemicals must be removed and the pathogens destroyed. That's why it is important to make informed and responsible decisions when choosing the right subsurface treatment system for your property. The first step for any property owner in identifying the proper type of subsurface treatment system, or SSTS, is to contact a Minnesota Pollution Control Agency licensed SSTS designer. This professional will come to the property and evaluate the site for the new system. The following factors will dictate where and what type of system a property owner will need to install. In order to properly determine your system's placement, you must adhere to the current setback standards. These standards determine how far the septic system must be set back from things such as property lines, structures, wetlands, shorelands, wells, neighboring wells, easements, underground power and phone lines, and road right-of-ways. Before deciding on what type of SSTS is right for your property, a few questions must be asked in order to narrow the SSTS selection process. How will the property be used? For example, is the property seasonal or year-round? Is it a private home or a business? How many bedrooms are in the dwelling? And how many people will be using the system? Knowing how the property will be used will help to determine the amount of sewage flow that will come from the property and limit the SSTS options for the property. What type of soils are present on the property? The soils and the depth to seasonally saturated soil conditions on a property will also dictate the type of system a property owner may install. For instance, dry soils or soils with no saturated soil features within 4 feet of the ground surface may allow for an in-grade type of drain field. Soils with seasonally saturated soil conditions less than 3 feet to the ground surface would require an above-grade drain field. Soil information is also needed to size the system and maintain the required 36-inch vertical separation from saturated soil conditions to the bottom of the septic drain field. 36 inches is the minimum amount of unsaturated soil needed for the treatment of wastewater generated on a property. Finally, is the property flat or is there a slope? Calculating the slope of a property and determining how flat or steep it is will be the one last important factor in system design and location. Once the site and the soil evaluations have been conducted, the designer and property owner can then discuss the options available for the size and type of system to be installed. There are many subsurface treatment systems to choose from, and the one you choose will depend on your property's unique characteristics. Subsurface treatment systems fall into 5 different categories. Type 1 systems are trenches, seepage beds, mounds, at-grades, and gray water systems. All Type 1 systems must have at least 1 foot of seasonally unsaturated soil to be constructed on. Distribution media can be approved rock or MPCA registered and approved proprietary distribution products. Soils with less than 1 foot of seasonally unsaturated conditions may require systems with advanced design and/or pre-treatment components as part of the system design. Systems designed for these soil conditions would be Type 3, 4, or 5 systems. These types of systems would require operating permits. Operating permits are renewable permits with requirements for system maintenance and monitoring to ensure the system is functioning properly. Type 2 systems are any systems installed on permeable soils or in floodplain areas, privies, and holding tanks. Type 3 systems are systems with flow restrictions or reduced sizing, and systems or mounds installed on less than 1 foot of seasonally saturated soils. Type 4 systems are designed with Minnesota Pollution Control Agency approved and registered pre-treatment distribution products. Some examples of a Type 4 system are media filters, constructed wetlands, and aerobic treatment units. Type 5 systems are experimental systems with an engineered design. Once a system design is completed, the design and an application for construction of an SSTS must be submitted to the St. Louis County Environmental Services Department for review. Once approved, a permit to construct the system will be issued and the property owner can hire a licensed MPCA SSTS installer to construct the system as designed. St. Louis County SSTS inspectors will perform a construction inspection when the system is installed to verify location and code compliance with the system before issuing a certificate of compliance on the new system. A well-designed and properly constructed subsurface treatment system is a fundamental component to any developed property. A properly designed, constructed, and maintained SSTS is important to maintain the health and safety of the public while ensuring a clean environment, today and in the future.
What this video showed is that the septic tank provides primary treatment of the settling of the larger materials in the sewage. The effluent from the septic tank, or the fluid leaving the septic tank, basically still has many of the problems associated with sewage, such as high degree of bacterial count, virus count, and a fair amount of solid materials and nutrients are also still contained in the effluent that leaves the septic tank. Therefore, what actually provides treatment with our systems is actually the soil underneath our drain field types of systems. That's what provides the lion's share of our treatment. To do this, we need 3 feet of a suitable soil between the bottom of the system, the bottom of the drain field discharge point, and what's called the limiting layer in the soil. That limiting layer is one of 2 things. It's either a seasonally saturated soil, or a water table, commonly known as a water table, or to bedrock. If your soil cannot provide this 3 foot of separation distance, which is needed to get rid of all the pathogens that are found in the sewage, then the system has to be elevated either at grade or elevated above grade with mound sand to make up the difference that you're lacking with that 3 foot separation distance. Also, surface waters need to be protected from phosphorus and sewage, because sewage contains a fair amount of phosphorus. If the phosphorus reaches a lake, excessive aquatic growth can take place, and you can have eutrophication and have the lake kind of turn green on you, which is not very palatable to most Minnesotans. So besides surface water, there's also groundwater that we do need to protect, and that's being protected from the nutrient nitrogen. Many private residences rely on wells, private drinking water wells on their site, and therefore if the nitrogen from the sewage enters their drinking water supply, it could cause them health implications and health problems at that point. So therefore the main goal of the ISTS rules and program is to kind of match the problems in sewage with the treatment that is necessary to take care of those problems. One of the primary and most critical elements of SSTS design is the protection of public health by avoiding sewage contact with humans or vectors that can later transmit that disease to people also. The primary elements in our code that rectify that or mitigate that type of situation is we do not allow any sort of direct discharge to the surface waters or to the land surface of any sort of sewage with our systems. Also, there's no sewage servicing of any sort, so if the system is under stress, it's weeping out into the backyard. That's also another situation that is not, it would be called a non-compliant system in the state of Minnesota. If sewage is backing up into the dwelling, that's also another indication that the system is non-conforming and is a health hazard. And that there's no physical safety hazards with the system, such as a cracked maintenance hole cover or maintenance hole cover that's slipped off and people can get access to the tank, especially a small child. That's also an acute safety hazard, and that's also covered in our code also. So if the system fails any one of those compliance issues that I just spoke about, then the system is classified as an imminent threat to public health and safety. Okay, next topic, we'll talk a little bit about drinking water. As stated, for soil systems receiving the septic tank effluent, that a 3-foot vertical separation distance is required to get rid of all the nutrients and the pathogens that are contained in the sewage itself. For existing systems, though, we do have more flexibility given to us by the state legislature, so that the 3-foot can be reduced to 2 foot in some situations. And also there's more flexibility given in that 3-foot separation distance if you provide pre-treatment of the waste with an advanced treatment device such as an aerobic tank. If you do not meet the separation distances that I just kind of described as a system failing to protect groundwater, those systems also include such things as cesspools and sewage pits, which are deepened, open bottom pits, generally sitting right into the water table itself. So those are also considered systems failing to protect groundwater. Now, what you need to remember, which is maybe not readily apparent, is that the water table in Minnesota fluctuates on a yearly basis. And so what we do, we design on the very highest level in the soil that occurs on a regular basis. That's for a prolonged period of time, usually a few months. So we can do our site evaluations and soils work throughout the year, because when the water table rises in the soil and it stays there for a long period of time, year after year after year, then basically it leaves a staining in the soil, or it leaves the soil kind of a grayish color. And so our designers are trained to look at those soil features and determine what that height of the water table is in the spring time of the year, and then our design is set off of that highest level. Typically occurs in the springtime of the year. Next, we'll talk about time periods for upgrading from non-conforming systems. So again, we have two types of systems that are an imminent threat to public health and safety, and those that are failing to protect groundwater. So the first is systems that are imminent threat to public health or safety. The time period to upgrade those systems is 10 months, and that's set by state statute. So that's a statewide thing that really has no flexibility in that number. It's 10 months. If you are a local unit of government, you can reduce that to something less than 10 months in your local ordinance if that is your desire and discretion to do that. For systems failing to protect groundwater, the state statute also says that a time period needs to be mandated for that upgrade also, but that time period can be set by the local unit of government. So many local units of government choose a time period right around a 2-year period, and some require less than 2 years to upgrade those periods, but for a system failing to protect groundwater, that is a choice that's done by the local unit of government. So in a nutshell, what is our environmental outcomes? If you want to sum this all down, is what do we really want to have happen with septic systems? There's really basically two things that we want to have happen. We want no exposed sewage on the property itself, and we don't want any sort of pathogens or nutrients entering the groundwater. So that's really the two outcomes that our whole program is geared to try to achieve. To help do this, we have design standards that are written in Chapter 70, 80, and 7081, but we also require setbacks to things that are can be potentially contaminated, such as wells and lake setbacks. Okay, now we'll summarize session number 4 here. So the summary is, sewage contains pathogens and nutrients which must be treated. The protected resources are number 1 is people, and that's protecting people from surface contact with pathogens, or contact with pathogens being a drinking water supply well due to contaminated groundwater. The second thing is we're trying to protect lakes, and again, we're trying to protect lakes from nutrients. And so if we don't do that, again, the aquatic growth will be enhanced, and the lakes will turn green. Again, that would be not something that is favorable to most citizens of Minnesota. So what is the goal of the program? The goal of the SSTS program is to keep the sewage below grade and not to expose sewage to the people or to vectors. 2, keep pathogens from entering the groundwater. 3, keep phosphorus out of the lakes. And 4, keep people safe, i.e. no cracked tanks or any sort of electrical hazards if you have electrical devices associated with your system. So we'll complete session 4 with our quiz. And question number 1 in our quiz is, the main treatment component of an ISTS is the septic tank. Is that true or is that false? Question 2, proper soil type and unsaturated soil conditions are important to remove pathogens from sewage and protect the groundwater. Is that a true statement or a false statement? And 3, if a dwelling discharges sewage to the surface, it would be considered as which of the following? Number 1, would it be acceptable practice? 2, would it be considered an imminent health threat or safety system? 3, would it be a code compliant system? Or 4, would it be a system not meeting the requirements of soil separation distance and seasonally saturated soil conditions? This ends session number 4, and thanks for viewing.